Training one AI model can use tens of thousands of GPUs running for months and cost hundreds of millions of dollars. That's more computing power than most countries have ever used for anything. So why does AI need so many GPUs? Why can't it just run on your laptop? Let's break it down. No tech jargon, just simple explanations. What a GPU actually does. First, let's understand what a GPU even is. GPU stands for Graphics Processing Unit. It was originally built for one job, rendering video game graphics, drawing thousands of tiny triangles and pixels on your screen, all at once. Here's the key idea. A regular computer chip, the CPU, is like one super smart chef cooking one dish at a time, really well. A GPU is like 10,000 basic cooks, each making one small part of a huge meal, all at the same time. For graphics, that means calculating the color of thousands of pixels simultaneously. Turns out, AI needs almost the exact same kind of math. What AI is actually doing behind the scenes? AI models, like the ones that generate text, images, or chat with you, are built from something called a neural network. Think of a neural network as a giant web of tiny decision makers called neurons, all connected together. Sometimes there are billions of these connections. Every time the AI thinks, it has to do a mathematical calculation across all of these connections, multiplying numbers together, adding them up, and passing the result forward. This is called matrix multiplication, a fancy term for doing tons of simple math problems at the same time. And guess what GPUs are amazing at? Doing tons of simple math problems at the same time. So instead of solving these billions of calculations one by one, which would take forever, a GPU splits the work into thousands of tiny pieces and solves them all in parallel, at once. There are two stages where GPUs matter. First, training. This is when the AI is learning. It reads massive amounts of data, like books, articles, images, and adjusts billions of internal settings to get better at predicting things. Imagine trying to teach someone by having them read the entire internet and adjust their understanding after every single sentence. That's roughly what's happening, except it's done mathematically, billions of times. This step needs massive GPU power because the model is adjusting itself over and over, using huge chunks of data at once. Second, inference. This is when you actually use the AI, like asking it a question. This needs way less power than training, but it still needs GPUs because the model still has to run those same billion connection calculations just to give you one response. Why one GPU isn't enough? So why not just use one really powerful GPU? Two reasons. Reason one, size. Modern AI models are so large, they literally don't fit in the memory of a single GPU. It's like trying to fit a library into a backpack. You need multiple backpacks to use working together, each holding a piece of the whole thing. Reason two, speed. Even if a model did fit on one GPU, training it would take years instead of weeks. By splitting the work across thousands of GPUs, companies can train models thousands of times faster, turning years into weeks. A simple analogy to remember. Here's a simple way to picture the whole thing. Imagine building a massive sandcastle. A CPU is like one person with a shovel, building it carefully, piece by piece. A GPU is like 10,000 people, each placing one grain of sand at the exact same time. Now imagine the sandcastle is the size of a mountain. That's a modern AI model. You're not building that with one person and a shovel. You need thousands of hands working simultaneously. That's why AI needs so many GPUs. Not because the math is hard, but because there's an almost unimaginable amount of simple math happening all at once. So next time you hear about companies buying 100,000 GPUs just to train one AI model, you'll know exactly why. It's not magic. It's just massive parallel math happening at a scale humans have never built before. If this helped make sense of it, hit like, subscribe for more simple tech breakdowns, and drop a comment if you want a video on how AI chips are getting even more specialized. See you in the next one. Thanks for watching.